Good morning. In this lecture, design considerations or rules in extrusion based additive manufacturing processes is presented. First design consideration is staircase effect on angled features should be considered. So the vertical features and angled features are differentiated here, and angled features in metal extrusion form is given in figure C, and angled features in stereolithography process is given in figure D, and angled features in PPF powder bed fusion process is given in figure D E, and the angled features create problems in the designs. The stair stepping error should be minimum in the printed parts. To avoid minimum stair stepping errors, consider this case and consider a planar volume. The stair stepping volume is a sum of each stair step. So stair stepping volume is a sum of each stair step, and stair step volume V equal to surface area into L layer height into cos theta. Theta is an angle, and divided by 2. It is a function of stair stepping area is a function of surface area and inclination angle on the surface made with the built plane. So it is preferred to have that angle equal to 0. So the designer should consider that angle features. The next feature is layer height. The designers should consider that layer height. So the first one will be the 3D CAD model, and the second one, the diagram B, figure A is ideal sphere, figure B, sphere sliced at 0.8 mm layer height. So it has more printed lines over that, and figure C, sphere sliced at 0.25 mm layer height. Compared to B, the C layer height is very less, 0.8 to 0.25 mm. If layer height is reduced, very minimum printed lines will be seen on the parts. So layer height should be considered in the design. Then the layer height, the simplest parameter to influence a printed part. The reduction in layer height, finer details with a higher accuracy and surface finish will be obtained. Most 3D printers have their default layer height. The third consideration, design consideration, is the residual stresses. See the diagram, the first hot layer and the second one cold layer, and the cold layer is placed over the hot layer, and fourth one cold layer. So here there are no residual stresses. The design should be such that there should be no residual stresses would be present. If residual stresses are present in the printed part, it will generate a defective printed part. Then the residual stresses create warping. If residual stresses are present, it create warping on the printed parts. So it should be controlled by controlling the surface temperatures. Then the fourth one, shrinkage and warping. Curing. As a layer of printed part is cooled, shrinkage and warping will occur. So sufficient allowance should be provided for curing. Temperatures will also play an important role in the warpage and shrinkage and warping of printed parts. So some temperatures should be controlled. Then multi-gating is a problem and it should be controlled and should be avoided to reduce the shrinkage and warping. And fillets, sharp corners should always be avoided. The sharp corners will create problems in the printed parts. Fillets, for this reason, fillets. So figure A, outer fillet is given. A fillet is given, always a fillet is given in the design to avoid such problems. So sharp corners have higher stress concentration, but fillets have very less stress concentration at corners or edges. So sharp corners should be avoided and corners and edges. It helps in fillets helps in assisting removal of parts from the built platforms very easily. That the fillet should be included in 3D design of parts wherever possible. Most technology produces natural fillets on edges and corners. More than fillets are and chamfers. Figure B shows the chamfers, and chamfers are highly preferable. Chamfers are also highly preferable because the chamfers does not require the support structures. Okay, it is a less than it is at 45-degree angle. So if the angle is more than 45-degree, you need to give support structures. So the angle is exactly at 45-degree, no need to give support structures. Thank you.